Good afternoon, everyone, and welcome to today's Assa Abloy Academy webinar on positive pressure fire doors. My name is Katie Flower, and I am your lead instructor for today's session. I also have Chad Tibbetts in the background helping support the questions and answer. If during the presentation you have a question, please feel free to type it in. You have a Q&A button at the bottom of your screen. And if Chad doesn't answer you directly, he will save the questions for the end. I've got about 15 minutes I save at the end of the presentation for any questions and answers that you may have. I wanted to start off with a few housekeeping items. Within 24 hours of this session, which is being recorded, it will be on the Assa Abloy Academy website for you to review as often as you would like. And you just go to Assa Abloy Academy, VILT, click on that, and on the top right-hand corner is a link to all of the recordings. Additionally, you can register for any of our upcoming sessions. We usually have 2 per day, sometimes more frequently than that, and sometimes only 1. But the schedule is published on an ongoing 2-week rolling schedule. Here's the next week and what it looks like. There's all kinds of classes, not just code related, but products, sergeant, cylindrical locks, exit devices, features and benefits of the 8200 mortise locks, as well as starting on August 17th, we are reprising the hardware applications for hospital 8-part series. You do need to register for each one individually, but they are 1-hour sessions. And each session is recorded, so if you do miss one, you can play catch up if you need to. Within 24 hours of this session, you will also receive an email thanking you for your attendance. Please make sure to check your junk email. And you can use that for continuing education, self-reporting for all of the majors, including AIA. If you're an architect, just send them the email and they will accept that as 1 credit hour. When it comes to codes, and especially when it comes to positive pressure fire doors, it is really difficult. You really can't memorize codes per se. The more frequently that you look at them and reference them, the more that you will get to understand them and know where to look. And hopefully the whole purpose of this class is to show you where you go to look to find information. But it can get very confusing, especially when there are many definitions that we need to understand. So before we get into the requirements of positive pressure fire doors, I do want to review the different types of walls that you will come across in a commercial building. Whether you are an architect designing the building or a door hardware distributor trying to detail the doors and frames, or a specification writer trying to select the appropriate code compliant doors and hardware, you need to understand these definitions. And each of these types of walls really depends on where within the building it is most commonly used. A firewall has a fire resistance rating and protected openings. Whenever we hear protected openings, that's our fire door assemblies, and that includes the door, the frame, and the hardware. And protected openings is synonymous with, when we say separated, we're typically saying separated with fire barriers or firewalls and protected openings. A firewall restricts the spread of fire and extends continuously from the foundation to or through the roof, with sufficient structural stability under fire conditions to allow collapse of construction on either side of the wall without collapse of the wall. Firewalls are used to divide a structure into 2 separate buildings. The division must be vertical. The requirements for a firewall are much more restrictive than those for fire partitions and fire barriers. And because of this, the opening protectives, our fire door assemblies in a firewall, are the most restrictive than those found in other wall types. And that makes them less common as well. A firewall, when you look in the tables, which we will shortly, is either going to be a 4-hour or a 3-hour construction. And it isn't all that often that we have 3-hour rated doors. But if you do have them, they're the maximum rating allowed by the codes or required by the codes. A fire barrier is fire resistance rated wall assembly of materials designed to restrict the spread of fire in which continuity is maintained. Fire barriers are used to compartmentalize large spaces into smaller fire areas to restrict the spread of fire, thereby creating a horizontal exit. They're also used for enclosures such as vertical stairways, exit passageways, exit ramps, and other similar separations. Most commonly, when you think of a fire barrier, you should think of exit. In buildings that are 3 stories or less, the fire barriers will be 1-hour walls with 1-hour doors, and in buildings of 4 stories and higher, they will be 2-hour walls and 90-minute doors. And when we get to the tables, I'll show you where you find that information in the code book. You can also see fire barriers used to separate rooms and spaces that may contain combustible or flammable materials, such as storage rooms and laundry rooms and the like. And again, there is a table which I will show you where you can reference it in the code, in the International Building Code, so that you can bookmark it and find it easily when you need to. So if firewalls offer the most protection, a fire barrier is the middle of protection when it comes to the different firewalls and fire barrier types. A fire partition is a vertical assembly of materials designed to restrict the spread of fire in which openings are protected. Fire partitions are used as wall assemblies to separate adjacent tenant spaces in covered and open mall buildings, for example. They also separate dwelling units. They separate sleeping rooms, like in a hotel occupancy, in a residential hotel occupancy. The rooms have fire partitions, the corridor walls are fire partitions, and the doors are typically 20-minute rated exit access doors. They're also used to enclose elevator lobbies. The opening protectives in a fire partition are less restrictive than those for fire barriers and for fire walls. They are the lowest level of fire protection rating that we have. If we look in the table in NFPA 80, which is the standard for fire doors and hardware, and the standard is referenced by the code, by the International Building Code, and when it is referenced by the code, it becomes a part of the code and a part of the law. This table shows us that fire doors and windows are classified with either fire protection rating that's either expressed in hours or fractions thereof, and they could have a letter designation, which you find on the label on the door, or a combination of both. So a Class A door is 3-hour rated, and that would be found in firewalls. Your fire barriers will have either B or C label doors, depending on where they're located within a building. B label doors are used for exits, vertical and horizontal exits. And as I mentioned earlier, if it's a building that's 3 stories or less, the walls are 1 hour with 1-hour B label doors. 4 stories and higher, and this is every door, whether it's on the first floor or more. When you've got a building that's 4 stories and higher, all of the doors and walls will be the same vertically. 2-hour walls with 90-minute doors. And then your C label doors are 1-hour walls, 45-minute rated doors. I'll show you the tables here shortly on where those are located, but those would be laundry rooms, storage rooms, and things like that. Exterior fire rated doors are not as often. You will find them if the building is in a busy city within 10 feet of another building and you have an exterior door in an alley to prevent the fire from spreading from one building to another. That would be a fire rated door opening, as well as if you have a door onto a fire escape at every level as you're walking down the stairs, that would be a fire rated opening. But most commonly, exterior doors are not fire rated unless they meet one of those locations. And then the last rating, it has no letter class designation, but a 20-minute, 1/3 hour door is the lowest level of protection. It's both for fire and smoke, and it's most commonly used in exit access corridors. Oftentimes I get the question, why is the door not rated the same as the wall? And that has to do with the fuel load. A door, you're not allowed to stack boxes or flammable materials in front of or behind a door. But the wall, you can stack boxes and furniture and different things in front of a wall or behind a wall. And therefore, if there is a fire, that adds more fuel to the fire, and the wall has to resist more than the door. And that's why it's critical, if you've got a door that you're no longer using, rather than just put furniture and pile stuff in front of it, it needs to be sealed off and rated the same as what the wall is rated. And NFPA 80 is where you find that. There's a few more definitions. The fire resistance rating is the period of time that a building element, a component or assembly, maintains the ability to contain a fire, continues to perform a given structural function, or both, and as determined by ASTM E119, NFPA 251, or UL 263, which are all tests for building elements such as walls, floors, and ceilings. Assemblies rated under these tests are deemed to be able to perform their function for a specified period of time under specific fire conditions. Doors and frames and hardware have a fire protection rating. Fire protection rating is the period of time that an opening protective will maintain the ability to contain and confine a fire as determined by the tests specified in section 715. And those tests, the standardized tests, are NFPA 252 and UL 10C. The ratings are stated in hours or minutes. And as I mentioned before, the label could also have a letter classification for the area within the building where that fire door is located. In the United States, all fire doors prior to the year 2000 were tested under neutral pressure, which is the atmospheric pressure is held right at the top of the door opening. So what happens is they take the door assembly and it's installed in the wall. The wall is clamped to the furnace. The gas is turned on, and within the first 5 minutes, the temperature inside the furnace reaches 1,000 degrees. Now, when heat and smoke rise, they're going to hit the ceiling, and normally they would start to push the neutral pressure plane down. But in the neutral pressure test, the flames and the smoke are ventilated out the top like a chimney. And so you never really get that neutral pressure plane any lower than the top of the door assembly. And what that does is that allows cool air to be sucked in from underneath the bottom of the door and that 1/8 inch gap at the top of the door into the furnace, and then it mixes with the gas and the hot smoke and the hot flames and is ventilated out of the top. That's not real world. And in the year 2000, when we switched from the 3 legacy codes to the International Building Code, that's when they changed the requirements for all doors, all swinging doors in the United States, to be tested under positive pressure, which is the UL 10C. And what really happens in a fire, when the hot smoke and the gases and the flames reach the ceiling, they start to push back down. That neutral pressure plane stabilizes right around 40 inches above the finished floor. And that's what the test replicates. So the neutral pressure plane at 40 inches makes it so that now you get the cool air being drawn in from underneath the door, but the hot smoke and the flames and the gases can push through that 1/8 of an inch at the top of the door. In order to pass the positive pressure fire test, I'm sure you've heard the term intumescent. The intumescent gasketing is required on certain doors in order to make it so that after the first 5 minutes, when that fire side gets really hot, the intumescent will start to expand. And the easiest way to picture intumescent, if you've ever gone camping and you've taken a marshmallow and you've toasted it, it starts off at one size, and you get it hot and it starts to expand, it starts to get black and starts to bubble, and then it expands sometimes to twice its size. That's what intumescent does. It will expand, it will start to bubble, and it will seal off the opening so that hot smoke and flames and gases will not come through the top or sides of the fire door. Some more definitions. We have two more types of walls. A smoke barrier is a continuous membrane that's either vertical or horizontal, such as a wall, floor, or ceiling assembly that is designed and constructed to restrict the movement of smoke. Smoke barriers are used as a component to form smoke compartments in buildings, and in healthcare occupancies, hospitals, and nursing homes, smoke compartments can be used to relocate people safely and promptly during a fire. It's called compartmentalization and an area of refuge. So typically a smoke barrier will be a 1 hour fire resistance rated assembly, and the doors will be rated as well. The lowest level of all protection is a smoke partition. It is a continuous membrane designed to form a barrier to limit the transfer of smoke. It does not carry any fire resistance rating. It is intended to provide less protection than a smoke barrier and is not required to be continuous through the concealed spaces and through the ceiling. The use of smoke partitions is limited and most commonly used in I2, which are your healthcare occupancies, nursing homes, and hospitals most commonly. And once again, they do not require a fire protection rating, but they do need to limit the transfer of smoke. I worked for 11 years with ASSA ABLOY. Before becoming a trainer, I worked for 11 years as a specification consultant. And whenever I received plans from an architect, I would draw out in color my different fire barriers, my fire partitions, my smoke barriers and smoke partitions. And that way I could see if there's continuity. I could make sure that if there's any doors within that different color, that they were rated on the door schedule, or I applied the appropriate fire rated hardware and door assembly that needed to go there. It's just a really easy way to visually check and see where your compartments are located and that they go from one side of the building all the way to the other without any gaps. In Chapter 7 of the International Building Code, that is where you will find a chapter, a separate chapter for each of the different firewalls has its own chapter, fire barriers has its own chapter, fire partitions has its own chapter, smoke barriers has its own chapter, and smoke partitions have their own chapter. And Chapter 7, 716, is all about opening protectives. That's our fire doors and hardware. And this table, 716.5, shows the fire protection rating for doors in the various types of walls that you have. Remember the definition of a firewall. A firewall is used to separate two different buildings, completely different buildings or apartment buildings. And when you have a firewall that's 4 hour rated or 3 hour rated, your minimum fire door needs to be 3 hours. This is where you want to bookmark this page and come back to it very frequently. Once again, it's very difficult to memorize all of this. It's much easier to make bookmarks, make yourself a tab, highlight in the code book where you need to go to find the information so that you can reference it quickly if you have a question. The thing to remember about firewalls and openings in firewalls, they're limited to 156 square feet, and the aggregate width shall not exceed 25% of the length of the wall. Now we look at fire barriers. Fire barriers that are 2 hour rated will have an 1.5 hour rated door. That's the 90-minute door. And interior exit stairways, which are made and constructed out of fire barriers. If your interior exit stairway is 2 hour walls, then your doors are 90-minute. And it tells you your limitations for glass unless otherwise tested by the door manufacturer. It tells you whether you can have a transom or side light or panel and what that would be And you have to look up your manufacturer to make sure that they can get to that. Additionally, if you've got 1 hour fire barriers, and that's when you have a building that's 3 stories or less, it's a low-rise building, so it's much easier to get out of the building faster. 1 hour walls with 1 hour B-rated doors, same square inches for glass, and other fire barriers, which I'll show you on the incidental use table next. Other fire barriers that are 1 hour rated have 3/4 hour rated doors. So these are not used in exits. Where do we find them? Chapter 5 is all about our incidental use areas. And table 509 is another table that you're going to want to bookmark. When you have furnace rooms with equipment over 400,000 BTU, then you either need 1 hour separation, which would mean a 45-minute rated door. If we go back to this, other fire barriers that are 1 hour rated walls would be a 45-minute rated door because it's not an exit. And that's what this incidental use table is for. So 1 hour wall, 45-minute rated door, or provide automatic sprinkler system. And in some of these, like in group E occupancies, E is educational, K through 12, including nursery school. Your laboratories and vocational shops that are not classified as group H, high hazard, you would either have 1 hour or automatic sprinkler system. If you're writing a specification and you've got an educational occupancy and you've got vocational laboratories in the building, if they're not rated on the door schedule, look at your wall partition types. If they're not rated, then highly likely that the building is sprinklered, and you could even look on the life safety plan to verify that. But it has to be one or the other. In some cases, like I2 occupancies, I2 is hospitals and nursing homes, laboratories that are not classified as high hazard are 1 hour and they need to be automatic sprinkler system. So in some cases, there's a trade-off. In other cases, there is no trade-off. It's both that you need. These would be 45-minute rated doors, and there would be an automatic sprinkler system. Laundry rooms over 100 square feet. You see these in hotels. You see them in other occupancy types. And so it's either a 1 hour fire barrier or sprinkler system, and the door would be 45-minute rated. The table continues and it talks about storage rooms and laundry rooms and other types of rooms. Just be aware where you can find the table, and then that's where you can use both tables together to determine the fire rating of the door. Our openings and fire partitions and smoke barriers are going to be very similar to each other. Fire partitions specifically used for corridor walls. The wall will be 1 hour rated or half an hour rated, and the door will be 20-minute. And these will be used most commonly in your exit access corridors. Anytime you have a hotel, the room door itself is a 20-minute door and the wall is a 1 hour wall. Anytime you have a school, exit access doors will be 20-minute with the 1 hour. There may be trade-offs for sprinkler system where you don't have any rating at all. And then other fire partitions, which would be on that incidental use chart that we just looked at, 1 hour with a 3/4 hour, 45-minute rated door. Smoke barriers are also 1 hour rated with 20-minute doors, but they're most commonly used to compartmentalize a building into 2 smoke compartments. No more than 22,500 square feet is the size of the smoke compartment. When we look at underneath the table 716.5, this is where they talk about fire doors and fire door assemblies constructed of any material or assembly component that conforms to the test requirements of this section and the fire protection rating indicated in that table 716.5. Fire doors, frames, transom lights, side lights, or both shall be permitted in accordance with the section. and fire door assemblies and shutters shall be installed in accordance with the provisions of this section. And here is our reference to NFPA 80. By referencing NFPA 80, the standard for fire doors and hardware, if you look in the chapter that has the references, it'll tell you which year that they're referencing, if you ever have any doubt. 716.5.1, this is still in the International Building Code. This is where the reference says that side hinged or pivoted swinging doors, which is the majority of the doors that we are dealing with, fire door assemblies shall be tested in accordance with NFPA 252 or UL 10C, which is positive pressure. We look at the blue text. The NFPA 252 could be either neutral pressure or positive pressure. And the only way to tell is if the architect also says that after 5 minutes into the NFPA 252 test, the neutral pressure level in the furnace shall be established at 40 inches or less above the sill. That is the determining factor which makes it scream, this is the positive pressure fire test. And that's the one on the right. So if you see UL 10C in a specification, you know that's positive pressure fire test. If it's NFPA 252, it has to say something additional to let you know that it's positive pressure. Any door that's not a swinging fire door, other types of door assemblies like swinging elevator doors, horizontal sliding fire door assemblies, fire shutter assemblies, bottom and side hinge chute intake doors, and top hinge chute discharge doors shall be tested in accordance with NFPA 252 or UL 10B, which is the neutral pressure test. And that's by and large not the types of doors that we are dealing with. We're dealing with swinging doors. Smoke and draft control. There's only one place in the code that talks about smoke and draft control, and that's very specific to door assemblies in corridors and smoke barriers. Our fire door assemblies require to have a minimum fire protection rating of 20 minutes. We're located in corridor walls, which is exit access corridor walls, or smoke barrier walls having a fire resistance rating in accordance with the table, shall be tested in accordance with NFPA 252 or UL 10C, positive pressure, but without the hose stream test. There are two parts of a fire test: the fire exposure for the time, whether it's 20 minutes or 3 hours, and the hose stream test. While that door is still hot, they shut the gas off in the furnace, they take the wall and they wheel it away from the furnace towards an open garage door, and they blast it with cold water from a fire hose at a certain distance from the assembly and on every square inch in a grid pattern. And they're testing the structural integrity of that fire door. It has to stay latched. It has to stay in the opening during not only the fire test, but the hose stream test. 20-minute doors in America, in the United States, do not have to meet the hose stream test. But any other door, 45-minute up to 3 hour, it does have to take and pass the hose stream test. In addition, our 20-minute doors that are used in exit access corridors and smoke barriers are required to have smoke and draft control tested in accordance with UL 1784. Louvers are prohibited because a louver will allow the smoke to pass straight through the door, and smoke is a leading cause of death in a fire. We do not want the smoke in our exit access corridors. As people are trying to get away from the fire, we don't want the smoke traveling down the hallway and catching up to them. Installation of smoke doors shall be in accordance with NFPA 105. NFPA 105 is another standard, and it is the standard for smoke and draft control. We'll take a look at that. Smoke doors shall be self-closing or automatic closing in accordance with NFPA 80. And it has to say this because some smoke doors do not have an actual fire rating. And whether it has a fire rating or not, if it's being used as a smoke door, this is referencing that you need a closer or some kind of closing device or an automatic closing device. Additionally, the opening between the bottom edge of the smoke door and the sill when the door is in the closed position shall not be required to be provided with a means to seal the opening. I get this question all the time. I put perimeter seal, do I have to put a door bottom? And the answer is, for the most part, no. And here is our reference, NFPA 105 4.5.6. There's a few different reasons for this. Number one, the bottom of the door, the clearance is 3/4 of an inch maximum. And 3/4 of an inch is not enough to allow enough smoke to get under the bottom of the door and make your egress corridor untenable. Smoke rises. And so therefore the bottom of the door is not a big target when it comes to the smoke trying to get out. And in addition, when that door is closing, it needs to close and either close and latch or close. And that creates an awful lot of friction. If you have smoke seal around the perimeter and at the bottom, it creates almost like a vacuum, and it makes it very difficult to close and latch the door. It is more important that that door be closed and or closed and latched at the time of fire. So those are the reasons why it's okay to have the bottom of the door not sealed, and in fact, it's preferred not to seal the bottom of a smoke door. There is one case when smoke door assemblies are installed where pressurization is provided to restrict smoke movement. Those shall be required to have a bottom seal. Always check with your architect or whoever the design professional is. Not all smoke pressurization systems require door bottoms, but the majority of them will. And louvers are not to be installed on smoke door assemblies unless otherwise tested and listed. The label on the door will have the hourly rating. It will tell you, there will be a serial number. It will tell you who the third party that has tested, in this case, Warnock Hersey, independent third party test lab. This is the logo of the door manufacturer. In this case, it's Seco, so you could always call them to find out if there's any modifications that you can make to the door. The minimum latch throw will be listed on the label, as well as the hourly rating and maybe even a letter designation. Or equipped with fire exit hardware, that is proof to the AHJ that the door is reinforced for an exit device. Only labeled fire door frame shall be used. The frame itself does not have an hourly rating. It will take on the rating of the door, and you have to make sure to use the appropriate hardware and potentially seal so that you have the proper for that rating of that assembly. The methods of anchoring your frame shall be as shown in the listing, and this is straight out of NFPA 80. They give a couple of examples with the sheetrock penetrating a minimum of 1/2 inch. This is with steel studs, this is with wood studs, but they have other types of anchoring methods depending on the type of wall. The clearances between the top and vertical edges of the door and frame and the meeting edges of doors swinging in pairs shall be 1/8 of an inch, plus or minus 1/16 for steel doors, and shall not exceed 1/8 of an inch for wood doors. I get this question, why are metal doors allowed to have plus or minus 1/16? The way that they are manufactured, the steel is bent, and there has to be some manufacturing tolerances. The other thing is, steel will expand when it heats. And so what little variation that we allow in the clearance will be taken up when that door heats up. It will expand, and that gap will be decreased. Wood doors are machined, and they can be machined exactly to the 1/8 of an inch. So they don't need a manufacturing tolerance. Also, wood doors do not expand when they are heated, and therefore they need to be spot on. Clearances are measured from the pull face of the door. As if things weren't complicated and confusing enough, this is the requirements for positive pressure specifically. And the categories that they use have no significance to the rating on the door itself. As far as an A label door, we know is a 3-hour rated door. That has no bearing on whether it's category A or category B. Don't let the lettering mess you up. And again, have something handy that you can reference and look it up rather than try to memorize. But we do want to know and understand the different categories and what is required for positive pressure. A category A positive pressure door has no additional edge sealing system required because it has a built-in concealed intumescent, and that is, it doesn't apply to hollow metal doors because hollow metal doors will expand if they get heated, and it doesn't apply to 20-minute wood doors with an S smoke label and a category H smoke and draft control. What this does apply to is our 45-minute, 60-minute, and 90-minute wood doors that have a built-in intumescent edge. And this would be not just the vertical styles, but the at the top and bottom as well. Always consult the door manufacturer's listing for what they have tested and what their intumescent, where it's located. Most architects will want to specify a category A wood door so that this black concealed intumescent is hidden, and that way it's more aesthetically pleasing. You've got a beautiful wood door. You don't have to put anything on the frame other than potentially just a smoke seal. Intumescent seal is for the hot flames and fire. Smoke seal is for the early stages of a fire, and that is just trying to control the passage of the smoke itself. They're two completely different types of seal. A category B positive pressure door is when we have an additional edge sealing system required because there isn't anything that's built into the door. It's not concealed in the door. This does not apply to hollow metal doors because, once again, a hollow metal door will expand when it's heated. It does not need any intumescent gasketing. It does not apply to your 20-minute wood doors with an S smoke label and a category H smoke and draft control seal. But what it does apply to is a 45-minute, 60-minute, or 90-minute wood door that does not have the concealed intumescent. Instead, it's got a category G frame applied intumescent. We're playing alphabet soup this afternoon, and there is going to be a review shortly where you get to interact and answer a few polling questions. So make sure you're paying attention to this part. 45-minute, 60-minute, 90-minute wood doors, something like the Pemco HSS 2000 edge sealing. This is a category G frame applied adhesive backed intumescent. Number one, because it's frame applied, now you have something that's got a thickness to it, and it will potentially interfere with the door in the frame if it's not installed and adjusted properly, if your clearances aren't exactly right. But it's also something that isn't as aesthetically pleasing as something that's concealed. This is an option, and it is required if you've got a category B door without anything that's concealed. For smoke and draft control, now we're talking about a gasketing for smoke only, not for the fire, but just for the smoke. The Pemco S88 is an example of this. It is adhesive backed, teardrop shape, silicone, highly compressible. The door closes against it. It's used around the perimeter, not for the door bottom. And this is used to comply with NFPA 105 when they say that you need smoke and draft control for UL 1784. This is for your 20-minute rated doors. This is required for 20-minute rated doors. Smoke seal is not required on a 45-minute or higher rated door. So why do we use it? It's a best practice on all fire doors. When I was a specification consultant, I would specify the S88 for any fire rated door as a best practice. For one thing, it also cuts down on sound. Another, it cuts down on odor, and it cuts down on sight. So besides the smoke, and it's such an inexpensive insurance policy is the way that I would look at it. It's so easy to install. You use it instead of silencers on the frame, and it's good practice to use it, but it's only required on 20-minute rated doors. Let's take a look at a couple of specifications and what kind of language. If you're bidding a job, some architects still use the older language, some are using the newer language. You get a mixed bag out there, but whenever you see UL10C, that's positive pressure fire test method. That should be the first thing you think of when you see UL10C is I have to meet positive pressure. Here's another way. In the door part 2, the product itself, it's saying construction UL10C category A. Remember that category A has the built-in intumescent. That should flag you that you don't need to have in your hardware set a frame applied intumescent gasketing because it's already built into the door. And if it is in the hardware set, as a bidder, I would either ask the question or remove it. It doesn't need to be in both places. You don't need to have it inside the door and then also on the frame. Another specification, UL10C, but this time they're saying it's category B. Category B should be my flag to say, okay, it's tested under positive pressure. UL10C is positive pressure. Category B means that my wood door does not have a concealed intumescent. If I'm bidding the wood doors, I want to make sure that's clear because a category A fire door is going to be quite a bit more expensive than a category B. But I also want to double check, is it listed in my hardware set that I have the frame applied category G intumescent seal? Those two have to go together. Category B and category G, they go hand in hand, and you have to have both. Here's just another example of where they're saying category A on wood doors 45, 60, and 90-minute, and for category B for 20-minute doors that they can be category B. For pairs of doors, provide styles with concealed intumescent seals. So there's different ways that an architect can specify, but some of the key things that you're looking for, if it says UL10C, that's positive pressure. If it references NFPA 252, then they have to say 5 minutes into the fire, the neutral pressure plane must be at 40 inches or lower above the sill. That indicates positive pressure. Category A has the concealed intumescent edges. Category B, they need to have in the hardware set a frame applied category G intumescent gasketing. Now let's get you involved and see if you can answer these questions. The first one, what type of seal is required on a 90-minute B-label hollow metal door? I am launching the polling. I can't see who has answered each one, so don't be shy. Don't worry about it, but you can't change your answer. Take a second to read through. A, category A, concealed intumescent. B, category B, frame applied like the PEMCO HSS 2000. C, seal is not required. Or D, smoke seal like the PEMCO S88. C, seal is not required is the answer. And again, the reason for that is a hollow metal door will expand. Metal will expand when it's heated. It does not require the intumescent gasketing. So if you've got a metal fire door, it already meets the UL10C positive pressure. What type of seal is required for a 20-minute rated wood door? 20-minute is the key here. Let me go to my next question for you. What type of seal is required for a 20-minute rated wood door? Is it A, smoke seal like the PEMCO S88? B, category A, concealed intumescent? C, seal is not required? Or D, category B, frame applied like the PEMCO HSS 2000? Most of you said that A, smoke seal like the PEMCO S88, and that is correct. And the reason why is it's needed in order to meet NFPA 105 for smoke and draft control. And 20-minute doors are most commonly used in either smoke barriers or fire partitions for corridor walls, especially exit access corridor walls. The next question, what type of seal is used for a 45-minute rated category A wood door? Let me get the question up for you. Go ahead and answer. A, no seal is required. B, concealed intumescent in the edge. C, frame applied intumescent like the PEMCO HSS 2000. Or D, smoke seal like the PEMCO S88. What type of seal is used for a 45-minute rated category A wood door? Most of you said the answer is B, concealed intumescent. And again, that is correct. The reason why on category A, we already have the concealed intumescent. This applies to 45-minute, 60-minute, and 90-minute doors that are tested under UL 10C positive pressure. So we don't have to have anything extra. If it's a category A positive pressure fire door, it's already built in concealed. What type of seal is required for a 90-minute rated category B wood door? A, no seal is required. B, concealed intumescent in the edge. C, smoke seal like the PEMCO S88. Or D, frame applied intumescent like the PEMCO HSS 2000. And you guys are getting the hang of this. The answer is D, frame applied. We'll show you the slide that reminds us category B doors do not have the built-in intumescent, so they have to use the category G frame applied intumescent like the PEMCO HSS 2000, and that applies to 45-minute, 60-minute, and 90-minute wood doors. Have just a couple more questions and then we can open it up to see if you have any questions, but we've got a couple more for you. What fire test requires doors to be tested under positive pressure? A, UL 10B, B, NFPA 252 with the pressure plane at the top of the door assembly, C, NFPA 105, or D, UL 10C. What fire test requires doors to be tested under positive pressure? And yes, the answer is D, UL 10C. UL 10C is the test for positive pressure. Sometimes they'll say UBC 7-2 1997, but UL 10C 100% of the time is going to be positive pressure. Sometimes they'll say NFPA 252, but if they do, it's got to be with 40 inches, the neutral pressure plane at 40 inches above the sill. The neutral pressure test has the positive pressure, the neutral pressure plane at the top of the door assembly. So UL 10C for positive pressure. And the last question for y'all, that's my Texas coming out. If a specification asks for a category B wood 60-minute fire rated door, what category seal must be provided? A, category A, B, category B, C, category G, or D, category H. If a specification asks for a category B wood 60-minute rated door, what category seal must be provided? Most of you said C, which is category G, which is correct. And just to remind you where we got that, category B does not have concealed intumescent, and therefore we must do the frame applied, which is a category G edge sealing system, and that's for 45-minute, 60-minute, and 90-minute wood doors. I'll let you, if you have any questions, please type them in now. I don't see any, which is fine. If you don't have any, that's great. I do want to remind you that when it comes to codes, it takes a lot of time to build up your knowledge base. The main thing is, where do you find the answers? And most importantly, get to the point where you can find the answers quickly enough if you're working on a project. Whether you're finding the answers for yourself or to be able to provide to an architect to show them why you're using a certain thing or why you're doing something this way instead of that way. That's one thing, but a lot of times we want to reassure ourselves, whether you're detailing the project, writing the specification for the hardware, reviewing a set of submittals for somebody else that wrote the specification, any and all of those, we want to make sure that we are code compliant. Positive pressure fire doors can get very confusing with all the letters and everything that they're using, but rather than try to memorize it, just keep the information handy so that you can access it. Do we have any questions, Chad?
Question here, why are Joint Commission and CMS fire door requirements sometimes above the code?
Those have more to do with Medicaid and Medicare money, state funding for certain facilities, and most of those are hospitals and they require annual inspection. And so to meet their criteria, they require something over and above what the code in order to get state funding for Medicare and Medicaid.
Katie, I don't have any more questions right now.
Okay, I'll hang out for a few more minutes, but for those that don't have any questions, thank you so much for attending. Hopefully we'll see you again in another ASA ABLOY Academy virtual instructor-led training in the near future. And thank you for your time and attendance.